This is MEC 22, Starting System Operational Description. The first thing we're going to do is look at different circuits, and then I will go through the operational description. So the first circuit is the control circuit. This is where all the switches are. This is how we control everything. And so that includes all of the black area and the solenoid here. And then we have the power circuit. And the power circuit is everything in red, all the way from the battery here all the way to the field windings. And then we have the ground circuit. The ground circuit goes from the brushes all the way down to the body of the starter and over here back to the battery. So let's start with the controlling circuit. So I'm going to draw here in purple, and we're going to follow along, and I'm going to describe how it works. The control circuit is you turn the key on, and that allows current with your foot on the clutch or in neutral and park, allows current to flow through the fuse, through the switch, and down into the solenoid, through all the windings, and down to a ground. When that happens, a magnetic field is created around these windings, and that pushes the plunger up. When the plunger pushes up, it connects these two right across there and allows current to flow through the power circuit. The second stage is the power circuit. The power circuit goes once the control circuit is activated. Power circuit current flows through the positive battery cable, through the solenoid, through the wire into the motor itself. Once it gets into the motor, we go through the field windings first, to the brushes, through these field windings, to the brushes, and then it goes into the armature through the commutator bars. The commutator bars are sitting around here, and then current flows out through the ground circuit to the ground, and that leads us all the way back to the battery. Now, what happens in the starter motor itself? Well, we have two magnetic fields formed. Magnetic fields around the field windings and magnetic fields around the whole armature itself, because current is flowing through the armature. So because we have current flowing through the field windings, there's a magnetic field. Through the armature, there's a magnetic field. Those two magnetic fields interact with one another with the north and south poles, causing the armature to turn. As the armature turns, the location of the brushes on the commutator changes the north and south poles of the armature windings, and therefore it interacts differently with the field windings. And because it interacts differently, it causes the armature to turn a little bit more, and it consistently changes poles and causes the armature to turn, so long as you have your keys lined up, activating your solenoid so that current is flowing through into the field windings.